Okay, so we're going to continue our discussion about distributive property, although we're going to do what I call advanced distributive property. So we're going to tackle some decimals and fractions, and then we're going to look at how we multiply two binomials together. Okay, so let's just do a quick recap, and we'll get started. So if we have negative 2x times 2x plus 3, so this is what we're multiplying together up here, we can set this up. Negative 2x is one dimension, so it goes on one side. 2x goes on the other side, and 3 positive ones. Like that. So those are my dimensions. When I multiply these together, I'm going to get my area. So a negative x times an x is a negative x squared. And I would have a couple of those. And then I would do negative x times positive 1, and I would again get a couple of those. See if I can't clone them and make them a little faster. There we are. Okay, and we can see that for learning the distributive property, algebra tiles are pretty good for visualization. But we will need to move to a shortcut or a faster way. So if we count this up, there's negative 4x squared minus 6x. Okay, so we also looked at a shortcut. Could I just multiply this piece in? And the shortcut's really fast, but it's also prone to making silly mistakes. So you have to make sure you multiply an x by an x and get an x squared. Okay, so there are benefits and drawbacks to both methods. So we're going to try and push our shortcut skills here a little bit further. So if I want to expand, that means to multiply out, and simplify means try and clean it up so that it's as neat and clean as possible. So we're going to multiply 2.5 into all three terms. Okay, so I'm going to take a line. Because I'm still learning, I'm totally okay with taking extra lines to write out my thoughts. Okay, so there is what I have to do. Now this is three little problems. That's how I view this. Otherwise it starts to get overwhelming. So this is 2.5 times 4x squared. So only these numbers are going to play together. There's nothing with the x squared to influence or change it. So I should get 10x squared. Okay. Go to the second term. Again, same thing, only the whole numbers are going to play together. So 2.5, that's two groups of 8 and another half of a group of 8, so 8, 8, and 4. So that should be 20x. And then lastly, 2.5 times negative 10, so I definitely have a negative answer. And I'm moving my decimal place over one spot, so it becomes 25. Okay? If you at any time want to pause these before I start, by all means pause them, try them, and then we can compare notes. So this one's a little trickier because it has x squared or x cubes that have to get multiplied in. So I am going to, maybe I'll make that screen a little bit bigger, help see that. Okay, so I'm going to write it all out because I know that's a strong strategy for me. I don't make as many silly mistakes when I do that. So I'm taking the time to write it, and now I'm going to view this as two small problems. Okay, now I have to go really slow here. These numbers will play together, so 0.5 times 18, or half of 18, is 9. And now x cubed times x squared. We have to use our exponent rules. We're multiplying powers, so we're going to add the exponents. Okay, we're mixing a lot of things up here. That's what makes this stuff tricky. 0.5 times 5, so what's half of 5? Well, that's 2.5. And then x squared, now remember there's a placeholder of a 1 there, times x is x cubed. And if we take a quick look, everything after the coefficient needs to be the same to combine. So an x fifth and an x cubed are not the same. So this problem stops right there. Okay, so let's be careful with this one. This is 3x squared multiplied into both terms. So I'm going to take a line and rewrite everything that's happening. Okay, so if we look at that, I have two small problems now. I have a 3 times a 4 for a 12, an x squared times an x to the exponent 1. So when I multiply powers, I have to add the exponents. So that becomes x cubed. And then I have 3 times 5 over here for 15. And then x squared times, there's nothing else to multiply with the x squared, so it just stays an x squared. I check to see these are not like terms. I can't go any further. Okay, now if we look at something like this one, it has a fraction in it. We don't want to panic. It's just a number. Okay, that's all it is. So I'm going to take the exact same strategy. I'm going to write out my 3/4. I'm going to write out my 12x, making sure I write it in the top location. I don't want to let it drift around. I want to keep it really clear. Okay, and now we also talked earlier this year about putting placeholders in things. So we could put placeholders there to help keep track of that. When we look at the first term, multiplying fractions, multiply across the top, multiply across the bottom. Okay, so I'm going to do 2 steps at once here. So 3 times 12 is 36, divided by 4 gets me back down to 9. Okay, there are no x's that influence the x, so it just stays an x. Over here, 3 times 8 is 24, divided by 4 gets me back down to a 6, and there's my answer. So even though I started with fractions, I finished with a nice clean term. Okay, what about 3 terms? Again, if you want to pause it, go right ahead. Well, 3 terms, nothing changes. We just distribute to more terms. So this first term would be 6 times 2x, 6 times 5a, and 6 times negative 7b. Okay, so I would end up with 12x plus 30a minus 42b. And none of those are like terms, so you can't do anything. That's the end of the problem. Okay, so now a binomial times a binomial. This is more of a grade 10 topic, but it's kind of nice to introduce it here because it fits really smoothly with what we're doing. So we have to multiply these 2 terms together. And we're going to use our algebra tiles to do it because it makes it really easy to see. So I have x minus 3 times x plus 2. So you can see down the left side is the x plus 2, x minus 3 is across the top. And if you've bought in and tried this model, you could do grade 10 work this quickly. X times x is x squared. 1 times x is x. Okay, we can fill those in. X times negative 1 would be negative x. So I've got 3 of those right there. And then lastly, 1 times negative 1 is negative 1. Okay, and we fill those in. Now the only thing we really have to worry about here, okay, so if we write down the terms we have, x squared plus 2x minus 3x minus 6, is are there any like terms? And we can see right here, there are some like terms. We can see them in our picture that these 2 here will zero off with those 2. Okay, that's it. That's the hardest part of that question. Okay, so you'll end up with x squared minus 1x minus 6. And if that makes sense to you, you just did grade 10 work. Well done. Okay, so if you want to pause it and try your own, there is a shortcut I'll show you eventually, but we're going to try one more with the algebra tiles. All right, so let's try this. X times x is x squared, and I've got 3 x's I have to worry about here. So 1, 2, 3. Negative 1 times x, here's a negative x, and another negative x. And then lastly, negative 1 times positive 1 is a couple of negatives. Okay, so now let's finish up. Let's see what zeroes out. So I have 1, 2. So those guys will zero out. So I'm left with 2x squared plus 1x minus 3. And that's how we can do distributive property with binomials. Okay, now we can shortcut this. I'm just going to change that view. You don't have to use tiles all the time. You can also draw pictures. So this is a tile modification. So here's your x plus 3, x plus 2. I just wrote them out like our regular distributive property. X times x is x squared. x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. Okay, and that's a nice clean way, and then you can see really quickly those two guys are like terms. So we end up with x squared plus 5x plus 6. Okay? Now, there is a shortcut that looks like the arrow method. What you have to be really careful of is whether you miss a term. So when we do this, you'll notice over here there are 1, 2, 3, 4 terms when we initially multiply this out. So here's what FOIL looks like, and FOIL stands for first, outside, inside, last. I think I've got that written up here. So first, outside, inside, and last. Okay, and what it looks like from an arrow perspective, first, outside. So you would do x times x is x squared, x times 3 is 3x. And then you would do inside and last. And then you would have plus 2x plus 6. And you'll notice you get the exact same terms we got in the area model. I like the area model personally for grade 9 because it shows you there are 4 terms. A lot of people will miss terms when they do FOIL, but we still get the same answer. Cool, and again, that's more of a grade 10 concept, but we can explore it now. So if you want to pause it and just try these ones, you can do them with the little drawing, or if you want to make tiles up, or if you want to even try the shortcut, hit pause and give it a whirl. Okay, so I'm going to set these up. I really like the pictures. I think it's way easier. So x times x is x squared, negative 6x, negative 1x, and positive 6. Okay, and then if I collect like terms, I have an x squared, negative 7x, and plus 6. Okay, I'll do the second one. I'm going to do one more with pictures, and then I'll switch up to the arrows. There's 2x plus 9, x plus 5. So now x, now I've got to be careful here, x times 2x is 2x squared, x times 9, 9x, 5 times 2x, 10x, 5 times 9, 45. I only have 2x squareds, I have 19 x's, and I have 45 ones. And you can see with this question, we would not want to do this with algebra tiles. 45 little ones would be really, really inconvenient. Last one, I'll do FOIL. So there's first. That becomes 8x squared. Outside, negative 10x. Inside, negative 12x. Last, plus 15. Clean it all up. 8x squared minus 22x plus 15, and you are done. You've done some fairly high-end grade 10 work. Okay, last one, I think. What happens if we have a 2-term, a binomial times a trinomial? Well, if you notice back here, we had 2 terms times 2 terms, and we got 4 terms. Well, if we do this one, 2 terms times 3 terms should give me 6 terms before I clean it up. Okay, so it looked like this. X times x squared is x cubed, x times 6x, 6x squared, and x times negative 5, negative 5x. Okay, 2 times x squared is 2x squared, 2 times 6x, 12x, and 2 times negative 5, negative 10. Now the only thing that's really different in this is there might be more terms that can be combined. So I drop the markers here. So when I go to clean up my final answer, I have an x cubed plus an 8x squared plus a 7x minus a 10. And if you can handle that, that's grade 11 work. Okay, and you'll notice it falls right into the exact same strategies we use in grade 9. We just start making the numbers and letters a little bit bigger and more complicated. Okay, I'm not going to do this whole one. I'll just put the answer up in a second. But if we have a 3 terms times the 3 terms, we would expect to get 9 terms. And you will not see this in this course ever. I just wanted to show you how this works. There is some fun bookkeeping you could do. I'll try and be as fast as possible. If you can't follow it, don't panic. X squared times x squared, x to the 4th, minus 5x cubed, minus 3x squared. There's the first expansion. Second expansion. Now I'm going to do a little tricky bookkeeping here. I'm multiplying the 6x into all of these terms. And those of you who are really comfortable might see what's happening. If you don't, that's totally okay. This is well beyond where we need to go. It's just kind of fun to explore on where we can go with this stuff. So you'll notice I have 3 terms, 3 terms, 3 terms. And I've done some really cool bookkeeping here so that all of my like terms are lined up. So I can do this, oh boy, negative 30, negative 33, negative 32x squared, minus 23x minus 3. So if you're overwhelmed by that, don't panic. We're not going to do anything like that this year. That's a grade 12 level problem. But you could see once we understand distributive property, we could do some pretty complex stuff. Pause it, take a look. I think you'll find it's not as difficult as it looks like on the piece of paper or on the page in front of you. There's a lot of terms there. It gets visually overwhelming, but the actual skills you have. Okay, thank you for tuning in. I'll post a task with that. Oh, for the love of Pete, where is it?